Hello friends, welcome to this video. In this video we are going to discuss the valve standard, that is API 600, which is specifically designed for gate valves. Okay, so let us see what we are going to cover in this video. First of all, we'll try to understand the total scope of API 600. Then we'll look into various important salient features which are useful while designing the gate valves. Understanding the relationship between various standards. While designing a gate valve, we have to go to many ASME standard that we will try to cover, and we'll look into various factors which we need to refer in different standards. Then detailed discussion on valve stem types. Okay. Then there will be another detailed discussion on valve wedges. Then small case study on bonnet thickness calculations with respect to API and ASME 16.34. We'll take few practical examples to understand the difference. Then we'll look into various applicable clauses which are very important to design the gate valves. We'll try to understand the end connection requirements, then how we determine the inside diameter of the valve, then various type of wedge and body guides, what is wear travel and how do we calculate it, and how it is important in valve design. Then various type of stems which we need to design. There are many clauses mentioned in this API 600. Those we are going to understand and look into. Then we'll try to look into various clauses which are important for packing box and Lawton ring. Then fugitive emission requirement, which are new addition to this API 600. Then various type of valve operators. In the end, we'll try to understand valve material clauses. We'll divide it into two parts as 600 API 600 has done. We'll look into two parts, non-trim materials, then trim materials. So this is the whole agenda which we are going to cover in this video. I'm sure this is going to be very interesting one and will be very useful for everybody. Before proceeding further, let us go back to our previous videos where we have covered these four topics. In first part, we discussed what are valves and what are various definitions and classification. Then under isolation valves, we covered all gate valves, ball valve, plug, butterfly and ABB type. Then under regulation type, again we discussed various type of regulation valves, globe, needle, butterfly, diaphragm valves. Then under non-return valves, check valves, swing type, lift type, dual, non-slab and multi-port type check valves we have discussed. So now let us start with our main agenda, that is API 600, that is designed for gate valves. So let us start our discussion on API 600 with the scope. What scope is covered in this standard? Let us see. Let us first look into the name of the standard. Steel gate valves, flanged, butt welding ends, bolted bonnets. If you see, this is flanged ends, welded ends, and bolted bonnet. So this is the total scope actually which we are going to cover. This type of design is covered in this standard. So what other things it is going to cover? Design, materials, testing, inspection and examination, marking, preparation for shipping. So this is the total scope which is covered in API 600. So as you know, the gate valve is bidirectional valve, metal seated, slow acting, no throttling, bulkier design, tight shut off due to metal seating, then best suited as on off valve. This whole things we have discussed in detail in our previous videos. So let us see, as we have discussed, this is bolted bonnet. So bolted bonnet, if you see in API 600, we are going to cover the carbon steel 1/2 inch to 42 inch and 150 to 2500 pound class. So this is the category which this standard is covering. So if you see bolted bonnet is this type of gate valve. Here it is bolted, okay, and these are the end connections. We'll look into each and every parts detail in further slides. In 603, stainless steel and half-inch to 24-inch valves are covered for classes 150 to 600. If you see, this type is pressure seal bonnet. If you see, this is sealing is there because of pressure. Here, more the pressure, more is the sealing. But this is the type of gate valve, this type of sealing bonnet, which is not a scope of API 600. So if you see, this design is covered in MSS SP 144 style P. Okay, 2 inch to 36 inch, 600 to 3900 pound rating. So what we are going to cover in this video is API 600. So we are going to talk about bolted bonnet, flanged ends, and butt welded ends. So now if you see, we are going to cover various features which are already there in gate valves. For example, the bolted bonnet, outside screw and yoke, rising stem. We are going to discuss each and every part in detail. Non-rising hand wheels, single and double gate, wedge and parallel sitting, metallic sitting surfaces, flanged or butt welded ends. So these are few of the cases which are valve features which we are going to discuss in detail. Each and every part we are going to discuss in detail in coming slides. In API 600, there are few references for other standards. For example, if we are going to design the gate valves, we are going to cover API 600 along with ASME B16.34. Face-to-face dimension, API 600 tells us that we have to refer ASME B16.10. For end connections, end flanges, 16.5 and 16.47. For butt weld ends, we have to refer B16.25. And pressure rating, pressure testing, API 598. So these are few of the standards which API says we have to refer while designing the gate valves. So now let us see how API 600 tells about various stem types which can be there in gate valve based on the requirement. So let us see this type. This is inside screw, stem rising, hand wheel not rising. Okay, if you see, stem is not moving, hand wheel is not moving, but stem is rising as this gate moves up to open the valve. If you see, this is closed position, this is open position. As this is moving up, hand wheel is staying there, but the stem is moving up. So stem is rising, but hand wheel is not rising, and screws are inside. If you see, these screws are going inside. Inside means this under it is entering into the area where their fluid is there, pressurized fluid is there, so it is inside. If you see here, outside screw, the screw is not entering into the pressurized part where fluid is moving. Okay, stem is rising, hand wheel not rising. Same here, hand wheel is staying there, but stem is rising. Only difference between two is the outside screws are there, which are there outside the pressurized system. It is coming inside, this is outside. So this is the only difference between two. Third part is hand wheel and stem, both are not rising. If you see here, the screws are there inside the gate, and when it is closed position, the stem is inside the gate. When it is open position, stem is still inside the gate, but it is not rising out. So these are few of the valves. We can use different type of layouts. If we have space constraint, we can go for this type of valves, but we have to mention very clearly to vendor that we need this kind of stem. So this API 600 covers all these type of stems. If you see, we have various type of wedges, wedge designs. This is also mentioned in API 600 that we can go for this kind of arrangement. If you see, this is single piece wedge solid, this is flexible type, this is split type, and double disc gate. Now each and every type of wedge has its own importance. So there is based on various application, these solid, flexible, split or double disc gate wedge can be used. So now let us see in detail how each and every wedge can be used and what are their benefits and how we can use in different applications. So if you see, we are having three type of wedges. Okay, solid wedge, then flexible wedge, then split wedge, which we call parallel disc gate welds. Okay, so this based on this three wedge design, we have three categories of gate welds. So now why these are different, why these are required, what is the purpose, what are the drawbacks, what are the plus points, let us discuss one by one. Popular because of its simplicity and strength. This is very common design. This rotates and this comes down and it obstructs the flow. So this is very easy to design. This is very simple and very easy to design, and it's very strong also at the same time. Easy to manufacture, suitable for almost all fluids. Okay, although this is a topic of discussion for process team, but just to know whether it is suitable for all the fluids or not. Susceptible to leakages as it does not compensate for changes in the seat alignment due to pipe loads or thermal expansion. Okay, suppose there is a high temperature fluid is going on and there is some expansion or contraction take place, then this wedge may block inside the seats. So it may be, it may be at some point of time, maybe it is very difficult to open or close the valve. So in that case, it is not performing well. It may result into thermal locking. So thermal locking may happen in which wedge is stuck between the seats due to expansion of the metal. So this is one of the drawbacks also. It is very simple to manufacture, very strong and commonly used, suitable for all the fluids, but at thermal expansions it gets locked. It may get locked. So this is only drawback we are having with this kind of wedge, which is solid wedge gate valves. Then another part is flexible wedge gate valve. What is different here from solid wedge to flexible wedge? Cut on the wedge parameter gives more flexibility but compromises the strength. Here what we are having a cut in between. Okay, although we are adding this cut to have some flexibility, but it compromises the strength at the same time. It improves the sitting alignment. Why we are making a cut? As we have discussed here, there may be a misalignment with the sitting seats. Why we are giving here a cut? To have the flexibility to align the wedge with the sitting arrangement. So in this case, improved sitting arrangement is there. So often better leak tightness. Okay, when it is aligned with the sitting and it is doing better tightness, so leakage chances are very less. Performs in thermal binding situation. As we have discussed here, thermal locking may happen here. It performs better in case of thermal binding situations. Line fluid tends to collect in the disc. Okay, some fluid may collect here, which may cause some corrosion and may weaken the disc. So this is one of the drawback here in this kind of flexible wedge gate valves. Third part is split wedge parallel discs gate valves. Okay, what is different here if we compare it with these two wedges? Consist of two solid pieces. If you see, we are having two different pieces. These are two separate pieces here. Can be a wedge shape or parallel disc. This can be a parallel or can be a wedge shape. Parallel discs are spring loaded. If you see here, there is small spring in between the two pieces. This spring helps in better sealing. Okay, the wedge is sitting properly between the seats, so better sealing is there, so less chances of leakage. In case one half of this disc is out of alignment, the disc is free to adjust itself to the sitting surface. So again it is better and it is helping in the sitting arrangement, which were the major drawback here, seat alignment. So this is best in this thing. Freedom of movement of the disc prevents the thermal binding. So thermal binding, which was problem here, which is mitigated in this case. So that's why this one is better as compared to this thing. Although this is very easy to manufacture, this is having some complication. So some drawbacks and some benefits are there based on that, based on process requirement, based on other properties. We can select one of these wedges. So this was all about gate valves, which we have covered in this section. In this slide, let us see how we can calculate the valve body thickness. If you see, API 600 gives us few tables where we can get the wall thickness. Okay, with respect to size, with respect to rating, we can get the minimum wall thickness in mm and inches. So these are the DN sizes here. Inch sizes are mentioned in NPS, inch size. So we can get directly the thickness of the valve body. Okay, for example, for 1 inch 150 rating 6.4. Similarly, same is covered in 16.34 also. If you see same inside diameter, then class, based on this combination, we can get the thickness, minimum wall thickness. Now let us see which one we have to use and how these are different and how we can use these standards to design the valve body. If you see, we have taken two cases, 12 inch 600 pound valve, 14 inch 600 pound valve. If you see here, 12 inch 600 pound, 12 inch 600 pound is 23 as per 16.34. Okay, for 12 inch we have 23. Here if you see, for 12 inch it is 31.8. So that means API 600 is taking care all the corrosion allowances and all other safety factors, and it is telling us that we have to go for higher thicknesses. If you see 23 versus 31.8, there is a huge difference between the wall thicknesses. If you go for pipe thickness calculation for this much range, you will come up to 7 to 8 mm thickness. So already there is a huge margin for valves. Safety factor is taken in 16.34. But if you go for API 600 table 1, there are few thicknesses which are far higher than 16.34 thicknesses. So that means the factor of safety which is required to design the valve has already been taken care in 600, API 600. So we don't have to add extra corrosion allowances or any other allowances to come up to the final thicknesses. So we can refer API 600 to get the actual thicknesses. If you see here, 12 inch 31.8, the vendor has given 32, so that is nearly matching here. If you go for 14 inch 600 valve, it is coming up to 35.1. 35.1. So this vendor has already taken care of all the API 600 clauses to design the valve body thickness. Now if you see, API 600 talks about various body end types. Okay, if you see what are various body type, we have, as we have already discussed in the first slide, body end flange. This is flange end type, and this is butt welding ends. Okay, so let us see what are the various clauses which are already mentioned in API 600. If you see, for flange ends, body end flanges shall comply with the dimension requirement of B16.5 for sizes up to and including 24 inch. So if the valve size is 24 inch and it is flanged end, then we have to comply with all the requirements, dimensional requirements, which are already mentioned in 16.5. Then only means we have to refer this standard to design the valve flanged end. For sizes over 600, that is a more than 24-inch, body and flanges shall comply with the dimensional requirements of ASME 16.47, which is again a flange dimensional standard which we have to refer. There are two series, series A and series B. As you know, we have already prepared a detailed video on 16.5, various differences between 16.47 series A and B, and the link for that video is already given in the description. You can go and check to get into more details. Then API 600 says until unless it is mentioned by the contractor or client, raised face end shall be provided. If we don't mention anything, whether we have to go for flat end, ring joint or any type of joint, flange facing, it is clear that we are asking for raised face end only. Okay, at the same time, if you see butt welding ends, valves greater than 2 inch shall conform to the requirement of ASME 16.25. So this is again ASME standard which we need to refer while designing the butt welding ends. Butt welding ends for valves 2 inch and smaller shall conform to requirement of API 602. As we are working on API 600, there is a standard API 602 for smaller size butt welding ends. So we can refer this standard to design the gate valves for smaller sizes. So let us see what are the various clauses which are already mentioned in API 600 to calculate the valve inside diameter. Okay, as you see, we are talking about this dimension, inside diameter of a valve, which we are going to design based on API 600. As per API 600 clauses, for sizes up to 24-inch DN 600, we have to refer ASME 16.34. In 16.34, we are having this kind of table for all the sizes, for all the class rating. We can directly see size and reach up to the inside diameter based on the applicable class. So for classes 150 to 300, in sizes 26 to 30, means more than this, we have to refer again 16.34. But only difference is we can refer 16.34 for larger sizes for 150 and 300 rating only. For classes 150 and 300 in sizes above 30, that means 32 to 40 inch, we have to go back to API 600 table 3, which is here. So again, it is mentioned against size and class rating. We are having two class rating only, 150 and 300. So based on that only, inside diameter is mentioned. So this is how we can refer these two standards up to particular size and ratings. These two standards has to be referred and we can get the valve inside diameter. Now let us see what are wedge and body guides and what are the various clauses in API 600 to design wedge and body guides. If you see here, this is the gate which is moving up and down to open or close the valve. Okay, now if you see, this is touching with the valve body. If we don't provide any special guide on body of the valve and on body of the gate, then it may damage the valve body during the after. If we open or close few times, then it may damage the surface of the valve. So we need to provide the guide here. Okay, so the body and gate valve shall have guide surface to minimize the wear of gate seats during operation of the valve. Okay, this is a gate valve and we have to open and close during the operation, so that time wear and tear may happen and it may damage if we don't provide the wedge guide rib here. This is a wedge guide rib. to ensure the alignment of the gate and stem in all orientation without gate binding and galling. Okay, now what does it mean when there are larger sizes of gate valves? We have to mention the orientation also, because maybe if somebody at plant orients this valve horizontally or at angle or downwards, then the weight of the gate may damage the guide again. So we have to, it is always better to mention which orientation we are looking for, so that vendor can take care of special requirements. So manufacturer shall provide in their installation and operation manual any operational limitation. Okay, if we are going to orient this valve downwards, then we have to mention it in advance so that vendor can take care all the requirements. Now this is very important aspect, wear travel. Okay, API 600 covers the wear travel distances based on the table, but let us try to understand what is wear travel first. If you see here, okay, this is gate which is moving up and down to close or open the valve. This is seat which is supporting the gate when it comes down or up. So when we operate this valve few times during the life of the project, then it may get wear off. Okay, so there will be friction between two and it may damage the seat. So with the time there may be gap between the two. This will reduce, this will reduce, so there will be a gap, so that this gate will start moving downwards. Okay, if you see here, this is same center line, this is same center line, but the gate is a little down, it is coming down up to this point now. Earlier it was restricting it to this elevation, now it is going down. So this gap is there, which is called wear travel, the travel because of wear and tear at the interface of gate and seal. Okay, so avoid this, it may damage if it moves further down, it may damage the valve and it may result into the malfunctioning of the valve. So this API 600 talks about this wear travel. This is going to happen and we have to take care during design only. So if you see here in table 4, which is given in API 600, if you go for 4-inch size, which will fall here between 65 and 150, it has given wear travel 3.3. So generally what we do, if you see here, this is the point seat is there and this is the gate between the seat. If you see 3.5, 3.3 into 2, 7, we have added 7 mm. We generally multiply it by 2 just to add safety of factor. Here we are adding 7 mm to 5 and this will become 12 mm. So this is including wear travel and we can decide the length of the gate from this point. So this is how we are going to calculate the wear travel. So anyhow, this is helping us to design the valve safe for safe operation, so it doesn't malfunction during the operation. Now if you see, there are few aspects which are mentioned in API 600 which we need to take care while stem designing. If you see, it is a stem. Okay, this is a gate. If you see here, this stem is there and there is a joint between stem and gate. Now what is happening if a operator is opening or closing the valve? Suppose this is a closed position, okay, and operator comes and rotates it to open the valve. Okay, after few years this stem may get weak, okay, because of n number of reasons. there may be some damage between the stem. Okay, so suppose the operator comes and it starts rotating the valve to open it, rotating this hand wheel to open the valve or to close the valve. Now suppose it damages here, okay, at this joint. Then what will happen? This screw will go up and it will open. Operator will think this is now in open position, but it remains closed and it is damaged here. It and operator never knows that it is damaged. He thinks this is open now. So that means this API 600 is saying here the stem design shall be such that the strength of stem to gate connection and the part of the stem within the valve pressure boundary shall under axial load exceeds the strength of the stem at the root of operating thread. Okay, so this joint's strength should be more than the strength which is there in this part of the stem. So if by chance it gets damaged, so it should damage somewhere here so that it is visible to operator that it is damaged. So this is how this API 600 talks about the stem design. Now let us see what are the various aspects which have been covered in API 600 regarding packing and packing box. Okay, if you see here in this portion there will be some packing. Okay, API 600 talks about a few things which we need to take care while designing the packing box. The nominal depth of the packing box shall accommodate a minimum of 5 uncompressed rings for packing. Minimum of 1, 2, 3, 4, 5. 5 rings are minimum which are required. The packing box surface area is contact with packing material shall have a surface finish. So 5 rings should be there. This much surface finish should be there or smoother than this. So this is the main clause which have been covered here. Then it talks about the lantern ring. Okay, if you see here, this same packing arrangement is there and we are having a lantern ring here. Now why it is required? To if something is trapped here, this can be removed from this part. In order to accommodate the lantern ring, the packing box depth shall be at least equivalent to that of a minimum of 3 uncompressed ring of packing above and 3 uncompressed ring of packing below. So 3 uncompressed rings should be below and 3 on top of this lantern ring. So this is the basic design which is mentioned. These are the basic or minimum requirements which we need to cover while designing the gate valve based on API 600. So now this is something which has been added very recently in API 600, which is related to fugitive emission. If you see here, this is very interesting graph. If you see, this is source of fugitive emissions in a operating plant. This is minimum, this is maximum. This is minimum through pumps, flanges and others. So if you see, even minimum is very high if you talk about valves. Maximum is again very high if we talk about valves as compared to other source of emissions. So it talks about emission level of 100 ppm or less. This is a mandatory requirement which has to be covered as per API 624. Okay, so this clause has been recently added in API 600. We need to take care of fugitive emissions and we have to design our valve so that we keep our emission limits within this. Now there are many clauses related to valve stem operation. If you see, if operation by chain wheel, gearbox or power actuator is to be added to the valve, the purchaser shall be specifying this following as applicable. For chain wheel operation, now you see here the dimensions from center line of the valve stem to the bottom of the chain loop has to be mentioned. Okay, similarly for electric, hydraulic, pneumatic, all these actuator as per requirement has to be mentioned very clearly in advance to the vendor so that these can be taken care. Okay, so this kind of arrangement will be there for this kind of requirements. So these are various things. There are many things which we need to mention. We need to analyze in advance what kind of hand wheel we are going to use to operate the valve, and we have to mention all these clauses into our requisition when we send it to vendor so that these can are not missed and can be taken care in advance. Now if you see, API 600 talks about material also. So we have divided into two parts: non-trim materials and trim materials. Now if you see, we have non-trim items, the body, okay, then bonnet. All right, so there are things which are not in contact with the fluid, and these are non-trim items. So based on this 6.1 clause of API 600, it talks about non-trim materials which we are going to use while designing the gate valve. So there, for example, there are 21 items. Okay, whatever things which are non-trim items, this API 600 talk about each and everything in this table 7 and talk about what kind of material we are going to use. So this is very important table and we have to refer while preparing our data sheets. It is very useful while deciding the material type of valve body and other non-trim items. Now let us come to the second part where we are going to cover the material for trims. First we need to understand what are trims. Okay, when this is a valve body and fluid is moving, okay, whatever part or items which are going to come in contact with fluid, we call it trim. Okay, so wet items are trims. So trim is comprised of the following: stem, okay, this is always in touch; body sitting surface, okay, sitting surface is always in touch with the fluid; gate sitting surface, gate sitting surface; bushing and depositing welds for back seat and stem hole guide; small internal parts that normally contact the surface fluid. So this is the definition of trims for all the gate valves. Now let us see how we can decide the trim material. Now if you see, API 600 talks about trim materials. Okay, there is appendix annexure D, which is not mandatory but for information only. This annexure talks about material combinations. For example, these are the material for body, bonnet. Okay, then we can check the bolt material. At the same time, it tells us trim material designation. So once we know the trim material trim number, then we can directly come to table number 8 where we can refer this trim number and we can get the material for each and every item which belongs to trim. Okay, nominal trim, seat surface hardness, seat surface material, then seat surface casting, forging and welded, everything is mentioned. Then stem material, okay, then stem hardness, back seat bushing hardness. So once we know the trim number, we can refer to this table and we can get the trim materials. It is very easy to refer, so we don't have to remember all the trims all the time. We just have to know which standard we have to use and which table we have to refer. If we don't want to use this table, then we can check the fluid list which shall be provided by the process department at very initial stage, where trim number against each and every material shall be mentioned based on pipe specification. So that is the also one of the way to get the trim number. Once we know this trim number, we can refer this table 8, which is again there is in API 600, and we can list out the materials which belong to trim, which we have to use for particular valve material. Okay, for example, for this body material is this, trim number is this, we came to this table and we go to 8 and we refer the trim material. These are the materials which we need to use to design the valve. As you know, recently we have published a piping engineering topic clickable ebook where all these topics have been captured. Against each topic we have given a subtopic, subcategory, and against each subcategory there will be a question list here, against which we have a answer section here. Once you select the topic, any of the topics, you will get the subcategory, and against subcategory questions will be there, and to get the answer you just have to click here to get up to the particular video lecture where you can get the details of particular section. So it will be very easy to navigate through this YouTube channel. That is the only purpose of creating this ebook. So that is available in the description. You can download that book and you can use it as per your convenience. So everything you can, all the social media links are mentioned here. You can endorse me on LinkedIn. Okay, you can subscribe clicking here. So there are so many interesting things mentioned. Personal messages there, future topics, few self-improvement topics are there. So you can go through each and every topic in at a single place. So that is the only agenda of creating this ebook, which is available in the description box. So thank you for watching. Stay tuned. I hope you enjoyed this video, and many more are on the way. So see you soon.